Welcome back, students. Today, we're diving into one of the fundamental concepts in electrostatics, and that is Coulomb's law. This principle explains how charged objects interact with each other, and trust us, you don't want to miss it. Let's start by defining what Coulomb's law is. Simply put, Coulomb's law states that the magnitude of the electrostatic force between two-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Now, let's break it down further. The electrostatic force between two charges is with similar charges repelling each other and opposite charges attracting each other. Therefore, the product of charges is also important. Larger charges will have a larger force, while smaller charges will have a smaller force. On the other hand, distance plays a significant role. The closer two charges are, the stronger the force between them. The farther they are, the weaker the force. It's like magnets, the closer they are, the harder it is to separate them. To visualize this, let's imagine two charged objects, one with a positive charge and another with a negative charge. The positive charge will attract the negative charge, and similarly, the negative charge will attract the positive charge. The magnitude of the force is dependent on the amount and distance of the charge. So, that's Coulomb's law in a nutshell. Don't worry if it seems complicated now. Repeat it a couple of times, and you'll be a pro soon enough. But wait, how do we calculate the electrostatic force exactly? That's where the math comes in. Let's say we have two-point charges, Q1 and Q2, and a distance between them, r. The formula for electric force is as follows. F equals K asterisk, Q1 asterisk Q2 slash r squared. Where F is the electrostatic force between the charges, K is Coulomb's constant, and Q1 and Q2 are the charges of the objects, respectively. Don't worry if it looks intimidating. We'll break down the math and make it easy to understand. Visual, a whiteboard with the formula and example calculations. Now, let's see Coulomb's law in action. Imagine you rub a balloon on your hair, creating a static charge. If you hold it to a wall, it'll stick, right? That's because Coulomb's law is at work. The balloon and the wall now have opposite charges, which attract, causing the balloon to stick. Similarly, you might have seen people creating lightning with Tesla coils or rubbing a balloon on their clothes to stick them on walls. All of these actions happen due to Coulomb's law. It's not just limited to everyday examples. Coulomb's law plays a vital role in electronics too. For instance, electric circuits work based on the principle of Coulomb's law. If we have two charged plates in parallel in a circuit, the electric charge flows between the plates because they have opposite charges, causing a current to flow. Plus, Coulomb's law enables us to create electronic devices such as generators, batteries, and electric motors. All thanks to Coulomb's law. It's hard not to think about gravity when discussing fundamental laws. However, Coulomb's law works differently than gravity. Gravity is always an attractive force, while Coulomb's law can be either repulsive or attractive. The magnitude of the gravitational force is affected by the mass, while the electrostatic force is affected by the amount of charge. And while gravity is a weak force compared to the electrostatic force, its range is significantly higher.